Jansen. Today I'm going to talk about our work on the accuracy of Tor bandwidth estimation. This is joint work with my colleague Aaron Jansen. Both of us are from the Naval Research Laboratory. The main results of our study are that we found that Tor underestimates total network bandwidth capacity by about 200 gigabits per second, which represents a 50% underestimation in its bandwidth capacity. We found that most 20% of relays have greater than 50% variation in their individual bandwidth estimates, and we found more error associated with higher capacity relays, exit relays, and relays with lower uptimes, relays that haven't been around as long. Inaccurate capacity measurements can lead to suboptimal load balancing, which will affect the performance of all users using the Tor network. So it's important to have accurate estimation. We found these results through two primary contributions. The first is through an analysis of passive relay measurements using historical data published and available on the Tor metrics portal. The second is through an active speed test experiment that we conducted to measure all relays in the network. In this talk, I'm going to focus on the active speed test experiment that we conducted and the results, but I'll note that there are more graphs and analysis for both of these contributions in the paper. I'm going to start with definitions to help describe the problem. The forwarding capacity can be thought of as the true capacity of a relay. This is the max sustainable rate at which a relay can forward traffic, and this value is unknown, so relays must estimate this actual value. And they do this by using a heuristic called the observed bandwidth. The observed bandwidth is the maximum throughput that a relay has observed, that it has sustained for any 10-second period over the last 5 days. This observed bandwidth value is reported to Tor metrics every 18 hours. And Tor, the load balancing weights that Tor computes and clients use to choose relays are derived from this observed bandwidth value. The problem is that observed bandwidth does not equal forwarding capacity. There are cases where an underutilized relay will never learn its true forwarding capacity because the observed bandwidth is only based on observations. And so if there's insufficient client traffic on a relay, then it won't know that it can send more traffic if it hasn't ever done it before. And so any load balancing algorithm that produces load balancing weights based on this observed bandwidth value will be inaccurate. So to investigate this problem further, we formed a hypothesis that the predominant error in the network is to underestimate the true capacity of Tor relays. So to evaluate this hypothesis, we performed a speed test experiment where we flooded relays with traffic to drive up their observed bandwidth values. The speed test experiment process looks roughly like this. We have a single experiment machine with a gigabit per second of bandwidth. We modify a version of Tor to add a new cell type called an echo cell. And we run 10 clients, and each of them is paired with a relay that's running on our machine. The clients then build a circuit through a relay that we'd like to test, where the second hop of that circuit is the partner relay on our machine. And then it sends these echo cells encrypted for the partner relay through the test relay. The test relay forwards these encrypted cells like normal, and our relay just notices that they're echo cells and returns them back through the circuit. So this results in a significant increase in traffic flowing through the relay being tested. And this should drive up its observed bandwidth value that it reports to Tor. So we ran the speed test for 2 days in August 2019. That's the first shaded region here. Within 18 hours after our speed test, the bandwidth reports reported by relays started coming into the Tor metrics, and we noticed that the capacity observed by the observed capacity values increased as a result of our speed test experiment as expected. About 5 days after our speed test experiment finished, these bandwidth value histories became stale. These histories expired based on the observed bandwidth algorithm, and at that point, these bandwidth values went back to their regular, roughly their regular values. So through this experiment, we noticed that Tor underestimates its total capacity by about 50%. So this jumps from about, capacity jumps from somewhere between 300 and 400 up to almost 600 gigabits per second. We then evaluated on an individual relay basis how our speed test experiment affected their understanding of their capacity, and we found that the estimated capacity increased for almost all relays, some by a 10x or greater factor. So the dashed line here shows the same capacity before and after the experiment. All the dots are relays whose understanding of their capacity increased following our experiment. So most of these relays, because we pushed more traffic through them, they learned that they can actually support more traffic as a result of our experiment. We then looked at, also show that we discovered more capacity on higher capacity relays. So by taking the capacity measurement following our experiment, which is more reflective of the true capacity, we separated these relays by their rank into quarter buckets. And so this graph shows that the relays with the lower capacity, which is the solid blue line, we discovered relatively smaller amounts of capacity on those relays. And relays that have a higher capacity after our measurement, we discovered relatively more capacity on those relays. And then we also discovered that the load balancing weights changed significantly for many relays, again, some by a 10x or greater factor. This follows the capacity increases roughly. So relays whose capacity increased by a 10x factor will have their selection probability increase by roughly a 10x factor. And we found that, for most relays, their relay selection probabilities are increasing by at least 10%, some up to 100%, and some, again, by 10x or greater factor. So this represents significant inaccuracy in the previous load balancing weights. That's all I have. Again, the contributions are we've conducted an analysis of historical measurements, and we did an active speed test experiment. We found a lot of error and capacity underestimation. Our research artifacts are available on our website, and my contact information is also available. Thank you.